Welcome to Workplace Ergonomics. This is a presentation by Judith Smet-Weiss of the Pennsylvania OSHA Consultation Office. We will be having a PowerPoint presentation followed by questions and answers. The chat is open to submit questions. We will be answering questions through this chat feature. If due to the technical nature of the question, a more thorough response is required, we will post the answer on our website within 7 days of the webinar. Here's our training outline. Ergonomics and the OSHA relationship. What is ergonomics? How to know my company has an ergonomic problem. Types of screening and scoring tools. Tips for using screening and scoring tools. Musculoskeletal disorders. General engineering controls. Office ergonomics. Industrial ergonomics and engineering controls. And the webinar summary. Ergonomics and OSHA. OSHA could cite the General Duty Clause for ergonomic hazards. Section 5A.1 requires each employer furnish to each of its employees a workplace that is free from recognized hazards that are likely to cause or do cause death or serious physical harm. The standard can be cited if injuries have appeared in the OSHA 300 log related to the operation and the hazard, showing that injuries have not been controlled. Here's an example. An employee is required to flex both hands while holding a 25-pound object in each hand, 400 times a day or 50 times an hour. Position is entry level and no one stays in the job longer than a month. There is no break-in schedule for the position and no rotational schedule. Employees have been notably wearing soft and rigid wrist braces they brought in from home. A safety professional has completed the Rapid Upper Limb Assessment, or RULA, and results were a score of 7 out of 7, meaning engineering changes are needed immediately. This position has produced a recordable ergonomic injury on last year's company OSHA log. So what is ergonomics? Ergonomics is the science of fitting jobs to people. Encompasses the body of knowledge about physical abilities and limitations, as well as other human characteristics relevant to job design. Ergonomic design is the application of this body of knowledge to the design of the workplace, tasks, equipment, environment for safe and efficient worker use. Good ergonomic design makes the most efficient use of worker capabilities while ensuring job demands do not exceed those capabilities. An ergonomist is one who works in the field of ergonomics. Industrial ergonomics then is the science of fitting jobs to people within an industrial type setting. Office ergonomics is the science of fitting office type workstations to people in an office-like setting. Is there an ergonomic problem? So look for the following. Employees bringing in splints, braces, back melts from home. Employees self-medicating with daily pain relievers at work. Company not able to keep a particular activity staffed. No one wants to perform this work. Employees bid out as soon as they can from this position or activity. And seniors do not perform this task at all. Upon observation, employees shift work from one hand to the other or one side to the other to avoid overuse of the preferred hand or side. Calling in sick repeatedly or putting in workers' compensation claims repeatedly in a particular position or activity. Employees self-modify the task, i.e. they bring in their own work tools, they add a foot, hand, or wrist rest, or body resting place, and physically take unscheduled breaks. On the OSHA 300 log, look for musculoskeletal disorders coming from one task or one department frequently. So what are musculoskeletal disorders, or MSDs? Musculoskeletal disorders are injuries or illnesses to soft body tissue, such as muscle strains, nerve damage, carpal tunnel syndrome, Raynaud syndrome, tendons, ligaments, joints, cartilage in the knees, and spinal discs. So are there any risk factors that predispose employees to musculoskeletal disorders? There are some predisposing risk factors. For example, smoking decreases circulation. Medications such as vasoconstrictors, estrogen replacement hormones, anti-inflammatory medications, certain ocular eye medications, and allergy medications can all be predisposing the employee to musculoskeletal disorders. Also, thyroid disease, circulatory diseases such as hypothyroidism, coronary artery disease, arthritis, hypertension, and diabetes. Obesity, which is a high body mass index, sedentary lifestyle. This decreases circulatory efficiency, and a high salt intake, which increases high blood pressure. All of these are predisposing factors for musculoskeletal disorders. A little bit more about musculoskeletal disorders. MSDs do not include the one-time injury caused by slip, trip, fall, or other accidents. MSDs can differ in severity from mild to periodic symptoms to severe chronic and debilitating conditions. So how do I know if an operation of mine is an ergonomic concern? We can conduct screening and evaluation tools, and I want to tell you where you can find them. You can also email me and I will send you what I have. Tools are available at the Ergonomic Center in North Carolina State. The web address is posted here on the PowerPoint, www.theergonomiccenter.com. The phone number is as listed. They offer free tools. They also offer some other more advanced tools for a fee, but there are some free tools that you can pull in from this site. There are also lateral standards. For example, the NIOSH material handling tables are good for evaluating large muscle groups. It's limited when you're evaluating upper limb movements such as the wrist, hand, fingers, and forearms. But it will tell you if the task generally can be performed by 75% of the female workers, which is a well-known design standard in the industry. Generally speaking, 100% of male workers can use a system engineered and designed to the 75th percentile for women. So how do I know if an ergonomic concern is prevalent in my operation? Again, more screening tools. These are coming from well-known ergonomists. For example, the Rogers muscle fatigue analysis by Susan H. in 1992. It's more of a job evaluation technique to screen out high fatigue jobs before they become injurious. The strain index scoring sheet by Moore and Garge, 1995. It analyzes jobs with the risk of distal upper extremity disorders. And then there's the RULA, which is the Rapid Upper Limb Assessment by Matamany and Corlett, 1993, Applied Ergonomics. It's a great survey for screening out upper limb disorders in a task. It combines postures with muscle forces to give you a score for each side of the body, a 1 through 7. Score of 7 means you must re-engineer the task immediately, and a 5 to 6 score means if you don't reassess or redesign, you will soon see some injuries. A 3 to 4 score is a task that should be observed and possibly managed by rotation. And a 1 to 2 score is acceptable and manageable if it doesn't change in frequency or weight. Following is an example of what the RULA screening form does look like. Pretty easy to fill out from top to bottom and left to right. Just follow the instructions on the form and put your cursor in the boxes lower right-hand corner to activate the drop-down scoring menu. There's a nice little notes page in the center that you can use to record observations that day. Is it hot in there? Is it cold in there? Is it dusty? Are people using gloves? That sort of thing can be recorded in the notes section to remind you what the environment was like when you performed the screening tool. And right next to the notes section will be your grand score. So after you rate across from left to right, the upper body postures, forces, and the lower body forces on the bottom, they'll come together in the middle Just to the right of the notes section will be your grand score, and it'll be a score of 1 to 7. And right at the bottom of the page on the bottom right, the grand score is spelled out in summary form, what the score means. As I said, 0 through 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7. It's all spelled out and the meaning described to you in the grand score description on the bottom of the page. So here's a few tips for using screening and scoring tools. Try to pull in the Excel sheet, not the PDF when you go looking for the tool. Obviously, you can fill in the Excel sheet, you can't fill in the PDF. Make sure that the subjects understand this is not a medical diagnosis, but rather it's a screening tool. Helps you determine whether or not the company needs to redesign a task. Post the results without the names associated. Sometimes one screening tool or one screening or scoring session may not be enough to show adequate results. Find out when the task is being performed most from the department head or the supervisor or whomever, and screen during those time frames. Also, the weight of the tool may not always be equivalent to the force necessary to apply to it to move it. So use a handheld dynamometer, excuse me, or a digital force gauge, or even a fish scale in the same plane that the task is performed, whether it's pushing, pulling, lifting, what have you, to get a more accurate measurement of the forces that are required to get the object moving. This is a sample of a kit that I sometimes take to a site with me. It's on the left-hand side, the JAMR handheld dynamometer, very easily set up, doesn't require that you send it out to be field calibrated. To the right, there's a fish scale, some links of chain, quite a few S-hooks, and a tape measure. Tape measure is used to determine the height from the floor that we're asking people to lift, push, pull, or move the object, which is kind of important so you can tell what plane you're lifting, moving, pushing, pulling the object in. And in addition to this little kit, you can get a digital force dynamometer. You can also throw in some lifting straps, which may help you lift or move objects that don't have handles, that require some straps be applied in order to apply the dynamometer to the object. Basic engineering controls in the ergonomics field, they're the preferred method for controlling the hazard. Make physical changes to the task and act on the source of the hazard. They control employee exposure. They don't require a self-protective action. A self-protective action is reliance on human beings to protect themselves, and that may result in a point failure. An example might be, for example, relying on an employee to take a break when they feel fatigued or tired really isn't an engineering control. It relies on them to be very astute and aware when they're fatigued and they may not be. This is a diagram of what an office ergonomics setup should look like, both standing and sitting. On the right-hand side, the sitting posture is called neutral position, and this is what ergonomists are going for when they set up your workstation. You want to use a straight chair with support for the lower spinal curve. Check the seat's height, adjusting your seat so that your knees are equal with or slightly lower than your hips. And if the seat's height is not adjustable, you may have to use a footrest. Keep your feet flat. Avoid crossing your legs. Keep your ankles and elbows at right angles. And with the elbow at 90 degrees, the keyboard should be adjusted so that it's just below the fingertips with no wrist flexion. So you adjust the arm rest to maintain the proper 90-degree angle, and then you adjust the keyboard to obtain the correct key height just below the flat palm of your hand. When the work surface doesn't adjust, when the table, desk doesn't adjust, you're going to find yourself adjusting the chair using footrests, keyboard trays, and monitor stands in order to make all the necessary height adjustments to get the body into neutral position. It really is best if you can adjust the workstation and then adjust the chair, monitor, and keyboard accordingly. On the left-hand side, you'll see the standing height ergonomics adjustment chart, if you will. And if you notice, there isn't much difference between the standing ergonomics office setup and the sitting. You still have to have the body in a neutral position with the elbow at a 90-degree angle and the head facing straight ahead, with the monitor between 20 and 28 inches from the face. So there really is no difference between the standing setup, neutral position-wise, and the sitting setup, neutral position-wise. They are identical. You want the body to be, straight, rigid, eyes straight ahead, elbow at a 90 degrees, palms flat, and the keyboard just below the palms. So there really is no difference in terms of setting up both workstations. So some things you might consider if you're a large corporation that does a lot of purchasing for office equipment, you might consider adopting a company ergonomic furniture standard. What this will do for you is it will avoid wasting money on executive furniture, for example, that doesn't adjust but looks great. Executives work on laptops all the time. So if their workstation doesn't adjust, if they have this grand, fantastic oak desk, but the height doesn't adjust, what you're going to find is that you'll be making all kinds of adjustments with their chair, footrest, keyboard tray, perhaps installing one of those underneath the table desktop, and putting a monitor in place on a monitor stand in order to accommodate the fact that the tabletop or desk workstation does not adjust. So putting in a company ergonomic standard requires purchasing agents to purchase the right adjustable workstation so that you don't run into a lot of problems later on trying to get the executive's body into a neutral position. Create a standardized task chair, standardized table surfaces that you're purchasing that adjust in 1-inch increments, adjustable monitor stands, purchase those and not ones that don't adjust. Standardize the keyboard tray and the footrest that you're going to be purchasing company-wide. Remember that standing workers can't stand for a whole shift, so they're either going to need an adjustable stool or a chair at some point. Take advantage of huge cost savings this way from lot purchasing of approved furniture within the furniture standard. You can save a lot of money this way. Also be aware that just because a salesperson says something is ergonomically designed doesn't necessarily mean that it's going to fit the task or the person. So purchase a task chair that adjusts every which way but loose, and you're going to be better off in the long run. Neutral position is what you're trying to achieve in the setup, and then take breaks, and stretch as the day wears on. There's also an IT solution that can be purchased as part of your ergonomic furniture standard. You can recommend the purchase of something called ErgoSuite, and that's a trademark computer IT system package that's out there. The IT solution, ErgoSuite, reminds you when to take breaks and how to stretch. And it functions on number of keystrokes and number of mouse clicks. And at some point, just pops up on your screen and tells you, ooh, it's time for you to take a break. You've been typing too long, or you've been mousing too long, and it's time for you to stand up, walk away, stretch, and it will actually provide you with a series of sitting or standing stretches to do to alleviate the strain of typing that long or mousing that long. So it's a great reminder. Of course, the caveat is also that someone could just dismiss ErgoSuite the minute it pops up on the screen if they're annoyed with it. So It requires that people be trained in ErgoSuite and realize that it's for their own benefit that they pay attention to it and take the breaks when they're prompted to do so. Industrial ergonomics and engineering controls. This makes physical changes to the task. It's things like automation, conveyors, lift tables, material hoists, cranes, forklifts, robotics, sound buffers, anti-vibration tools, natural lighting, temperature and humidity control. These are all engineering controls in the industrial environment that you can utilize. Engineering controls act on the source of the hazard, usually not the employee. For example, one engineering control is the use of anti-fatigue mats, anti-vibration gloves, tool substitution, using the drill versus the hammer drill function on a drill, using Vibram anti-vibration soled shoes if you happen to be in an environment where heavy equipment is running past you all the time. You can't control that, so you put your employees in anti-vibration soled shoes. Maybe you're operating, trying to think, maybe you're operating a hammer drill or you're operating a jackhammer. You want those individuals protected from vibration with the use of anti-vibration gloves and potentially anti-vibration soled shoes. And Vibram is one trademark name of anti-vibration soled shoes that's out there. The pressure and nerve damage caused to the joints is crucial. Vibration causes inflammation, which damages the joints. You want to try to reduce or eliminate vibration in the workplace if you can. Other engineering controls, the material movement from beginning to end. We want you to push instead of pull if you're manually moving materials. And we also want you to engage in mechanical movement versus human movement of those materials whenever possible. And examples I gave earlier, here they are again: hoists, mechanical lifts, even wheelbarrows, lift tables, conveyors, robotics, for example. Lifts are best, human lifts, if they're performed in the knee to waist plane, avoiding the low lift below the knees and avoiding the high lift above the shoulders. Try to use a wide base of support if you're physically lifting yourself. Your feet should be 18 to 20 inches apart, roughly, shoulder width apart. Don't stand on one leg to lift. Make sure you're standing equally on both feet. And you're not standing on ladders lifting materials for long periods of time. So try to reduce or eliminate pulling, lifting and carrying, and try to utilize mechanical advantages that are out there for material movement when you can. Some other tips for reducing force and exertion. You can try reducing the weight of the object, the weight of the container, the load inside the container, the size of the container, and the quantity per container. Temperature. Temperature is another engineering control, often goes overlooked. Cold does constrict blood flow and slows human movement, and hot environments are just exhausting. So there's possible vascular and neurological damage that can occur, and workers with cold, desensitized fingers, may grasp loads with more force than necessary, which exposes your muscles, soft tissues, and joints to increased force. Add to this cold environment some possible synergistic things that people might be doing: consumption of alcohol, for example, nicotine, caffeine, and some medications also can increase musculoskeletal risks from cold temperatures. So I try to use the recommendation from ASHRA 55/2017. It recommends temperature and humidity. For example, the ideal indoor temperature in the wintertime should be 68.5 to 75 degrees Fahrenheit with a relative humidity of 40 to 60%. In the summer, you can use the range from 75 to 80.5 degrees Fahrenheit relative humidity 40 to 60%, and an airspeed of 30 feet per minute as a guideline. Keep reminding yourself that clothing, layers, and the level of work activity can drastically affect the level of comfort, even in the controlled environment. Lighting is another engineering control. Too much, not enough light can cause awkward postures, muscle fatigue, eye strain, mental fatigue. You want to try to use ANSI recommendations for office lighting requirements listed here. I pulled this table out of 1926.56 D3, which is a reference incorporated by reference from ANSI IES RP7-17. So what it does is it on the left lists the foot candles or candle power, and on the right side, your area of operation. It's a very good tool, very good guidance. Noise is an engineering control, and it does impact ergonomics, believe it or not. Approaching the action level of 85 dBA can actually cause increased muscle tension, quicker onset of fatigue, emotional stress, reduced concentration, diverted attention, and slower post-effort recovery times. So do your best, try to eliminate reduced noise in your work environment. Here's some interim controls that you can utilize in the absence of controls, engineering controls. The secondary response by an employer should be to use some interim controls to try to control ergonomics. Some of these are listed here: task rotation, mandatory break periods, break-in schedules. You can focus on quality versus quantity. No per piece production incentives should be allowed in a safe ergonomic environment. Use a stretching and flexing warm-up at shift start. Try to teach proper lifting techniques. If you do have to have human beings physically lifting materials, teach those techniques to them. Supply the correct glove for lifting and gripping. For example, ANSI provides a table in ISEA 105/2016 for the purpose of supplying the employer with a guidance document for selecting the proper type of glove for lifting and gripping. The use of a work hardening program is beneficial for those returning from injuries, such as carpal tunnel, for example, back injuries. So you want them to make sure that they're going through a work hardening program before just coming off the couch at home and going back into their full-time regular duty assignment. Try to control the product demand if you have that ability to be greatest an hour after shift start and lowest at shift start and 1 hour after shift end. There's a nursing study that was done in the 1990s that indicates that most of the nursing profession sustained injuries 1 hour before the end of shift. So that's pretty critical. It's a pretty good piece of information to have. So you want to make sure that the demand isn't as high as it is right toward the end of shift, an hour before shift change. Try to encourage injury and illness reporting and treatment. Obviously, if they're not reporting their illnesses and injuries and they're seeking treatment elsewhere or self-treating or self-medicating, then you're not getting the information that you need to determine if there really even is an ergonomic issue in your environment. So please do encourage injury and illness reporting and treatment. Here's our summary. We talked about ergonomics and the OSHA relationship. Told you what ergonomics is and how to know if your company has an ergonomic problem. We talked about types of screening and scoring tools and tips for using those screening and scoring tools. Discuss musculoskeletal disorders and general engineering controls. We talked to you a little bit about office ergonomics, and then we hit upon industrial ergonomics and engineering controls. The Pennsylvania OSHA consultation program, since 1983, the Safety Sciences Department has been the officially designated agency in the Commonwealth of PA for providing free occupational health consultative services made available through federal regulations. Here is how to contact the Pennsylvania OSHA consultation office. Here's our address, phone, web address, Facebook address, and Twitter address. And if you pull in this PowerPoint presentation, these are hot links. You should be able to go right to these resources for you. Thank you for joining me today. I hope that you picked up a few tips about ergonomics to help you in your environment. The upcoming webinar in February is going to be training in the modern day work environment, from learning theory and concepts to training analysis and evaluation. Will be conducted on February 12th, 2020 at 10:30 a.m. Thank you again. Have a good day.